Now let's talk about the fermentation types and the actual production process. In real life, uh, what is the actual process that normally goes on for fermentation process, and what kind of fermentations are used normally? So I would say that batch fermentation and fed batch fermentations, they are the most commonly used method in the industry. We'll discuss them both in detail. But the sequence, if we look at the sequence of this fermentation process, this would start. You have to sterilize your medium first. Then we inoculate the reactor. Then there's an incubation phase for the microbial growth. It has to pass through lag phase, log phase, and stationary phase. There's, as you know, are the normal growth patterns. Then the fermentation has to be terminated once the stationary phase has been reached. Then afterward, we drain the reactor for product recovery downstream, and then clean up of the reactor, and then this started. This process goes again and again and again. So this is how the flow of process happens in case of fed batch system as well as the batch fermentation systems. Now, how we calculate different things in real life, we have to look at the percentage yield that has to be calculated in terms of gram per liter of the final product, because we are more interested in this final concentration of this end product. So it has to be calculated by the concentration of product form. It is divided by the concentration of substrate consumed. That is multiplied by 100. So that would give you a percentage of yield of a specific product in your real time fermenter. Now, if we talk about the productivity of this fermentation process or overall process, it is measure of the product formation rates, like how quickly this product is being formed. So if we calculate this by dividing product concentration with the fermentation time, so we need to look at how quickly this fermentation has resulted in the end product. So that is going to be measured in terms of gram per liter per hour. So we have to look at how much liter of substrate was used, how many grams of the product has been made, and how many hours has it taken. So that gives us the productivity of the whole process. So if we talk about in fed batch fermentation, this is a little different than the batch fermentation. We have to add additional carbohydrates. So this is a little difference in the process of fed batch system, that you have to add carbohydrates. They have to be supplied during the batch fermentation process, during the run. Why we do this? Because if we add too much carbohydrate initially, that is going to be toxic for many growing microorganisms. So in order to reduce this initial load of carbohydrates to facilitate the growth of microorganism, this fed batch process is followed to get the optimum yield of end product and not destroying our useful microorganism who are doing this whole exercise for us. So that would be helping us. We start with the minimum amount of carbohydrates that give us the best maximum growth or best growth of these microorganisms in that concentration. And once this is utilized, we would add some more carbohydrate into this fed batch system. But it is important to know that once we add these fresh carbohydrates during the process, it has to be properly sterilized. If it's not sterilized properly, that can be a source of contamination for this fermentation process. So once this is done, we keep on repeating this process until there is enough formation of end product, and that might inhibit the further growth of these microorganisms. So that can be a limiting factor. But in fed batch system, as compared to the batch system that we earlier discussed, the end product is almost 3 to 4 times higher as compared to the batch type fermentation systems, because we keep on adding the desired amount of carbohydrates. So this end product keep on building up within this fermentation system. So you would have highest yield uh, in the system, which is possible because above that level it would be again stopping the growth of microorganisms. And you would have increased end product accumulation within carbohydrate addition. So ideally, in a process like this, we would want to have maximum concentration of desired product in the final end product with minimum amount of carbohydrates that can be there. So this would be an ideal outcome. Now let's talk about another method. This is unlike batch system. It is a continuous fermentation systems, or they are also called as open fermentation. We would be adding fresh medium continually. This is added to the bioreactor, and the spent culture medium can be constantly leaving this bioreactor, and it can be constantly collected. Now, this system is very much desirable, and this is highly favored by the industrialists. The reason for this is this system is 10 to 100 times smaller than the Fedbatch system, because in the batch system you are limited to add up all your batch at once. On the other hand, in a continuous system, you keep on adding the fresh raw material and you keep on getting the end product. So this batch, even smaller, it can be equally effective. So that is the reason that this process is very, very effective. The size is much smaller. It's comparatively easier to control, and there's a downstream process for recovery of the useful end products in the fermentation process. But the challenge again in this case is you have to constantly provide the sterilized, pasteurized culture medium, because if there's any error in this, that would lead to contamination of your product. And that would be related to the growth rate and operational speed of the downstream recovery process. So if you keep on adding this sterilized medium, that can be linked with the downstream processing of the fermentation process here. Normally, if we talk about the startup, this is slow. So any facility can shut down. It would have impact on production, and you would have to constantly fight with contamination. So although it's a difficult process, but still favored if you can properly control this kind of system, you can avoid contamination. This would be a far better option. But again, this is a little difficult than the batch system. That is a reason that all fermentation end products are not feasible for this continuous system. So if we look at the dilution rate that would be reducing in each bioreactor over the course of fermentation process. But this is very critical. This would build up in the culture medium. For example, ethanol, if you are producing, this can build up in the culture medium, and that would be slowing down the production of yeast. Similarly, if you look at the growth rate of these products, this is very much equal to the dilution rate. If you talk about this, some of the other things such as the carbon dioxide, it can be collected and concentrated, and it can be sold as another byproduct. So sometime you can target the byproducts as well. For example, this carbon dioxide can be sold as a byproduct just to augment the process, the price, so it can have some economic impact. Similarly, some of the other products such as wines and beers, they are still preferred to be processed in this batch system rather than continuous system. Similarly, one of the another requirement for this continuous process is to have more concentration, higher concentration of biomass within the reactor. That would be required because you are constantly adding the input or raw material. You would need the microbial cell biomass within the system to actually keep on working on those substrates. So higher concentrations are needed. Now, how we can actually achieve this? There can be different technologies such as immobilized cell technology. They can be there, or maybe you can use cell recycling reactors where you can add up these recycle cells back into this fermentation system, and then that could help you keep on carrying this process. But as I said, although it's preferred, but it's difficult to control, and it's not ideal for every kind of end product. So that is why we have to choose between whether we are going for a batch system or a fed batch system or a continuous system, depending upon the type of product, end product that we are interested in.